In this question we have Young's double slit experiment and we need to calculate the missing wavelengths, those wavelengths that will be missing in front of one of the two slits. Let's say this P is the point where we are trying to determine the wavelengths that are missing in front of this slit S1. For that, what we need to do, we need to find out the destructive interference at point P for the rays coming from S1 and S2, and then we will be able to solve for the wavelengths that will be missing. So the basic will be that first we will take the path difference. The path difference between the rays coming from S1 and S2 will be this much, and this will be d, where d is the distance between the two slits, and d times the sine of the theta between the two rays. So in this case, and other than that, this theta is very small because the point is not very far away from the center of the slits, or the center, this C point. So here the path difference will be d times sine of theta. The theta is the angle between the two, and for destructive interference at P, the path difference should be an odd multiple of lambda upon 2. So for odd multiple, we can write 2n minus 1 lambda upon 2, where n goes from 1 2 3 up to infinity. So this is the path difference, and for destructive interference it is odd multiple of lambda upon 2. Now since sine theta, if we look at this triangle, this one P, D and C, then sine of theta is PC divided by OP, where OP is the hypotenuse of this triangle. But since we have already assumed that theta is quite small, in that case this OP will be equal to the distance between the screen and the slits. So this will be D. So under the assumption that theta is very small, so sine theta can be this, and OP can be equal to D. So PC upon this D. Other than it, let's say the distance, the vertical measurement above C, we are taking it like, let's say y by. So this is y upon D, and from this figure you can see that this D upon 2 and this y, they are equal. So we can further write it like D upon 2 capital D. Now we can substitute this value in our original equation of the path difference. So we will have d squared divided by 2d is equals to 2n minus 1 lambda upon 2. On simplifying it, we can write lambda equals to d squared divided by d times 2n minus 1. So these will be the wavelengths which will be missing, and if we substitute the value of different n, like n starting from 1, then lambda 1 that will be missing, like d squared upon d, then lambda 2 will be d squared upon 3d, and lambda 3 will be d squared upon 5d, and so on. So these are the missing wavelengths that will be missing because of the destructive interference between the rays coming from S1 and S2 at point P.